So we're back to cognitive assessment, and we're moving from big picture to focusing in on the development of a single variable to measure cognitive impairment status. This variable is included in the cognitive comprehensive file. So a little bit on the rationale. So we at some point thought that the UAS could in fact be a very attractive resource for both cross-sectional and longitudinal research on dementia and mild cognitive impairment, as many longitudinal panel surveys on aging are. Now we have, compared to other aging surveys, we have the full adult lifespan from 18 to years over the entire adult lifespan, so that makes us a little different, but we thought that this could really be attractive if we had an indicator of cognitive status for respondents for research, for example, on risk and protective factors of mild cognitive impairment, on economic consequences and of mild cognitive impairment, and so forth. So we set out and wondered how would we assess cognitive impairment status in the UAS. And of course, clinical diagnosis we thought would absolutely not be practical because this would involve in-person interviews and it's often very involved. But we had already administered cognitive tests used in the health and retirement study. So, and the health and retirement study uses well-established cutoffs developed, for example, by Lange and Weir, or the so-called Lange and Weir cutoffs to categorize respondents into three groups. That's cognitively normal people, cognitively impaired with no dementia, or people with dementia. And I really want to emphasize this is not a clinical diagnosis, but it has proven very useful to look at prevalence rates of dementia and mild cognitive impairment and so forth in large sample research. So we wondered, could we kind of replicate what they did in the UAS? This is a slide that shows two of the core tests that go into this categorization of people into cognitive status groups. You have the serial sevens, which is very quick, where people are supposed to count backwards from 100 in steps of 7. So that's 100, 93, 86, 79, 72, 65. And if you get that right, you get 5 points. Then we have immediate and delayed recall of 10 words, 4 different word lists. So yes, so these are the two core tests here that we're looking at. And why can we not just apply the existing HRS cutoffs based on those tests? Well, main reason is the HRS is using telephone interviews or in-person interviews, and we are using online administration. So that was asked beforehand, could this impact the performance of individuals? And as you can imagine, it might well impact performance quite a bit when you're administering the word list, say over the telephone. People listen to the words and then they have to repeat the words later verbally. Online, people read the words and then type the words. So this could change the performance, of course, dramatically. So we did not just want to use the existing cutoffs, but we decided to approach a crosswalk between the HRS dementia categories and our UAS online cognitive tests, where we conducted a study where we administered the HRS tests via telephone with the UAS respondents, and then had the UAS respondents complete the tests over the web in randomized order within a 1-month period. So that's a within subject design. The sample size was 925 people. Everyone was age 50 or older, and there was some stratification by age, prior cognitive test scores, and difficulties with instrumental activities of daily living. This is an illustration of how the mode of administration can affect your scores. These are the scores for immediate recall, delayed recall in the serial sevens on the phone and on the web for the same individuals. where we had no idea a priori, but what came out is that the web scores were lower for the recall and higher, so that's about a third of a standard deviation higher for the serial 7s. So again, you cannot just use pre-existing cutoffs or scores on a different mode of administration and say this should apply to self-administered web tests, is what that tells us. So what we did then is, and I don't want to go into details, but we developed a crosswalk based on a latent variable model. This is graphically illustrated here, where you see the bubble on the left-hand side, which says web factor, is really a latent variable that is comprised of these 3 test scores. And what this allows us to do is map this latent factor onto the observed distribution of the scores based on the telephone administered tests. What it also allows us to do is we don't have to necessarily categorize individuals, but we can retain the scores as a continuous score. And I'm going to show you in a second what that helps maybe. But what it also allows is that we can incorporate more and more tests into this latent web factor. So on the right-hand side, you see that we added, for example, the instrumental activities of daily living problems score as being part of the web factor. The figure on the right-hand side is actually the score that you will find in the cognitive comprehensive file. This was the latent factor that performed the best in terms of having the best correspondence with the telephone scores. We also tried adding additional cognitive tests, and that did not help. So that the figure on the right-hand side is what you will have available because that performed the best. So what that yields then is what we call for each respondent, a probability of cognitive impairment score. So we're not saying this person has cognitive impairment, the person does not have cognitive impairment. We're giving you for each individual a score that gives the probability that a person has cognitive impairment. So this is a nonlinear transformation basically from the sum score of the tests onto a probability score. So if a person has a 0.7 score, for example, that means that the probability that this person has a score that would classify him as cognitively impaired based on the telephone is 70%. A note on these scores, of course, that's not going to be a normally distributed score whatsoever. This histogram here shows you the distribution of the scores in the current UAS sample, and you see it's very skewed, and it's bounded, of course, between 0 and 1. And it's, of course, very skewed because most people in the UAS have a low probability of being cognitively impaired, so that makes total sense. But since the distribution is not normal at all, I recommend using something like fractional outcome variables, or using the score as a fractional outcome variable, for example, using fractional logistic regression. And also as a reminder, we do not have proxy reports in the UAS. So if someone gets really cognitively impaired and maybe has dementia, they will likely not continue doing online self-administered cognitive tests, which means that the prevalent, if you were to use these scores to estimate a prevalence rate of cognitive impairment, this may not be representative of the US cognitive impairment rate in the adult population or in the older adult population. It may underestimate is what we would expect, but we haven't researched that to the extent possible. So these we call short PCI scores. They're available in the UAS cognitive comprehensive file, as I said, currently for one wave. And as I said, we're focusing on one variable. It's called R4 PCI. Additional waves we hope to add every 2 years. And if you really want to know about the details on how we develop this crosswalk, you can read them in this publication that's shown here that we recently published in the Journals of Gerontology. This citation is also in the UAS Cognitive Comprehensive File documentation, if you look for it there. Yes, again, a reminder, this is a summary cognitive status score for research purposes and should not at all be interpreted as a clinical diagnosis. But it's awesome and you're welcome to use it, and please contact us with questions. And I saw there was already a question in the chat. Someone asks, to clarify, UAS collects data on adults 18 years and over and not just middle-aged or older adults. That's correct.